REST API tutorial for beginners. It turns out that the whole part of REST is relying entirely on the HTTP request methods. These are sometimes often called the HTTP verbs, even though they can be a noun as well. These request methods are the get, put, patch, post, delete, and options and head. There's several other. Actually, they can be anything you want. They're just essentially request methods. And with the REST API, the REST specifically leans entirely on top of the HTTP spec. This gives you the opportunity to do things like issue API calls to read data, which often you'll use with the GET, the GET, all capital letters. This request method lets you read data from a URL endpoint. And then the POST method will give you the ability to write data to an endpoint. Now, this is all entirely based on the HTTP specification and the formats that are needed in order for you to interact and build an API with REST. That's really all it is to it. It just is very simple and it's clean, and basically the majority of the internet runs and relies on this approach on top of HTTP. So if we walk through it really quick here, we see that HTTP defines a set of request methods to indicate the desired action to be performed for a given resource. The resource is typically going to be the path, so it's like /user /ID of the user. That could be the resource. That's the path. Although they can also be nouns, these request methods are sometimes referred to as verbs. Yes, they can be nouns as well. Each of these implements a different semantic. So all of these request methods sort of have ideas behind them and concepts, sort of paradigms that were they intuit a common feature that are shared by a group of them. These request methods can be safe, idempotent, or cacheable. Now, a safe method is usually going to be a read-only method. That's just like as safe as you can get, which is going to be a get or an option or a head request method. Idempotent means that you can continuously make the same call over and over and over, and you'll always receive the same outcome, regardless of the number of times that you've issued the call. Cacheable means that the API call, once upon read or posted or anything can be cacheable. That means that the end server or a downstream proxy can cache that API call and make the API call faster to future users who run into it, because it's essentially idempotent in many cases, so it's going to be cacheable. If we go over a few of the options, we have the get, GET, all capital letters, usually meant for reading data. Even though you can use the get method to do whatever you want, you could just bypass it. You'll kind of step away from the REST aspect of it, right? The REST API has these sort of like known truths that allow developers to read data. Obviously, you could use a get API to write data as well. You totally could. You can even include a payload, and it breaks the spec, though it's just text, so you can kind of do whatever you want. Even the request method, like get, for example, you could make up your own. You call it maybe read, READ, all capital letters. You can use that too. It's just text. You can do whatever you want. Though when we're talking about REST APIs, they're just generally a few sets of standards. And of course, we'll want to go over more of those as well. What are the other options available? There's quite a few. What do you think are the next REST request methods? What are the next ones? What are the next ones available? Which ones do you think would be kind of standard? That's actually a really good question. Which ones do you think? When we're talking about REST APIs, there are a set of HTTP request methods that are sort of standard when it comes to building an API following the REST sort of pattern, if you saw the REST pattern. Does REST actually stand for anything? Before we go forward with listing out all the request methods, what does REST stand for? What does REST stand for? Does it stand for anything? Oh, it does! Representational State Transfer. Okay. Which is a software architectural style that sets guidelines for how an API application programming interface should work. It was created to help and manage communication on the internet, and it's one of the most common ways to build web APIs. It's so common that it's just very natural because it's just as clean as it can get, and it relies entirely on top of the HTTP protocol. So if we walk through all the different options that are available, now guess what? You can invent your own. You don't have to follow the standard. You can bring your own. You can do whatever you want. Here's the standard ones. We have get, of course, which is to read data. It's meant to only retrieve data. Head is a method to ask for just the header information, so without the body. So it's identical to get, just excludes everything below the headers. The headers are going to be content length, content type. Is the data actually available to read, right? So would it be a 200 or is there going to be a 404? So this is just the head information. It's going to say, hey, is there any data there? If there is, can you give me a little bit of metadata about it? And that's what the head request method does. Post is a write endpoint. So it's saying, I want to write data to a server. This method submits information, such as an entity, to the specified resource. A specified resource, this is going to be the path, the URL, /user/ID. That's the specified resource. And it will cause a state change with side effects on the server, means that you're writing data. So that data that you're going to write will mutate state somewhere by writing data into a database. Put is a method that replaces all the current state information of a target resource. In this case, it's kind of like, you could be an upsert. This could be an upsert. So it's very similar to post. However, this allows you to replace everything. And the idea is, even if there's other information there about a user, it means delete everything about that user. This is what I'm reading here in this case. You don't have to implement it this way, but what I'm understanding it is the method replaces the current representations of the target resource with the request payload. So if you want to completely replace a user and all their state and all their data on a server, you would use the put method. Now, if you want to do, sort of upsert and merge, there's a patch method. Is there a patch? Are they going to talk about patch here? They do. Okay. So the patch method applies partial modifications to the resource. So if you want to just update the name of a user, you would probably use the patch request method. Now, what other options do we have here? Delete. I wonder what that does. It deletes the specified resource. So /user / the ID of the user, it would delete that user. Connect is a method to establish a tunnel to the server identified by the target resource. You don't ever usually need to use this. This is not something that you would ever really run into. This is not ever a requirement. So you can kind of remember, these request methods can be anything you want. You can really anything. You can put anything there that you want, and then you can bind your own code logic onto what those request methods are going to be. Just kind of curious, what does the connect method do? So you wouldn't need to do this. Usually you don't. It starts, so the HTTP connect method, request method, starts a two-way communication with the requested resource, which means that essentially both client and server can start passing data bidirectionally back and forth in a way that sort of, it's escaping. It's like the escape beyond the HTTP protocol. So if you wanted to just start sending data back and forth through any kind of text format, that's what the connect method does. It's kind of neat. It's kind of a neat way to bypass HTTP altogether. You don't ever really need it in a REST interface scenario, though you can use it if you want. I recommend staying away from it. There's not really a need for it at this time. Options is a method that describes the communication for options from the target resource. That's not really a good description. Let's see if we can find something a little bit better. Okay, this is a much better description of what options request method can do. You send the options request method to an endpoint, a URL or path, right? /user. And with the options endpoint, it gives you a list of methods that are available to you for that endpoint. For example, can you read the data? Can you post data? Can you put data? Can you delete the data? This will give you a list of those request methods that are available, so you can use the options method to get a list of what other methods are available based on that resource. That's pretty powerful. I like that. That's clean. Typically, you don't need to, I mean, if you're using REST in general and you're building a REST API, you don't need to bother with knowing what's there. It's going to always be these three. You're always going to get post, put, delete, probably patch as well, for example. And then trace. What's going on here? We're getting into some very interesting items. Let's actually walk through. The trace method performs a message loopback testing along the path of the target resource. What's going on here? We're getting into some crazy HTTP request methods. Let's take a look at, maybe there's a better description of this one as well. Okay, the HTTP request method for trace is going to be used for diagnostics and debugging and troubleshooting. Usually when you're building probably a web server from scratch, you'll want to have a trace method, and it's really going to just give you back information about the server itself. Probably you can post a payload included with the trace request method, and then it will echo that back to you directly to the client. So you don't also ever need to use this. This is not necessary. You can do whatever you want. Remember, these are request methods. You can put any text you want in there, and it'll still count as being a HTTP request verb request method. It works the way. So that's what trace is used for historically. You don't really need to use it anymore these days. Of course, we talked about patch, and this is the final write endpoint, sort of like say you want to update a user, just their name or just their email address, and you don't want to delete any other information about that user ID. So that's what patch is going to do. It's going to give you the ability to just modify one of the fields of an entity like a user, comparing that to the put method, which will completely replace all the data. So say if you wanted to just update the email address and then you use the put verb, the put request method, it's going to delete everything about that user, and then it'll just have their email address there. And so if you ever run into that problem, you're using the wrong HTTP verb. You got to use the patch. Let's take a look at an HTTP request. It turns out it's just a bunch of text. And did you know that it really is? There's nothing more to it. The idea of just posting text between a client and a server is really straightforward. I kind of felt betrayed when I learned about this, because there's all these web frameworks out there that feel like they're doing a lot of work for you, and it turns out they're just structuring a blob of text that's going back between a client and a server and parsing the blob of text. It's really, really as simple as that. Let's look at the blob of text that's being exchanged back and forth between a client and a server. So here's a request. This is a client using an REST API call to a server, and it starts off with the request method at the very beginning. So we're looking at the request method. As you can see here, just some capital letters. It says get, G-E-T, all in capital letters. And did you know it can be anything you want? There really can be anything you want. Typically in a RESTful API, there's a set of standard methods that we use, including post, patch, put, and delete. And that's where that request method goes. Yes, this is the very beginning of the string, the beginning of the text. You can open a text document and write the word GET, and you've begun making your first HTTP request. Isn't that crazy? The next segment here, delimited by a space, so you just simply put a space, and this next path this section is going to be the path or the URL or the resource. So you're going to have this data here that is going to be like /index.html, /user ID, lots of options. Basically anything that's going to identify the action you want to take on that entity is going to go right here. Next, beside that, we add another space right here. So there's a space here, we have a space here, and so you've noticed that this first line will contain two spaces, delimiting the request method, the request path, or the URL here, and the protocol. Now the good news is with the protocol, it's always pretty much going to be in, well, there's newer protocols with HB2 and HB3. Just to keep things simple, we're going to start with HB 1.1. This is going to say what the version of the API call is going to be in terms of the HB protocol itself. There's only two options And they do have impactful meaning. You're either going to have a 1.1, which is the newest option available for HTTP 1, or 1.0, and it does have an impactful meaning. Now, you have another delimiter here, which is invisible, you can't see. This is a new line carriage return here. And then it's going to start with our first header. And that header is going to look like this. It's going to be the host header. This is mandatory when you specify HTTP 1.1. You have to have a host header. If you specify HTTP 1.0, you don't have to have any headers at all. Not even a host header is required. This is, with the 1.1, host header is the only thing that's required. Also, you might be wondering what goes as the data inside the host header. Whatever you want. You can put whatever you want there. Some web servers will require you to specify it based on some telemetry or other kinds of configuration. In this case, it's just your domain name. You just put your domain name there. So it's also delimited here by a space and a colon. So you've got host colon space and then the name of the domain. And that's all you need for an HTTP request GET method. Then you'd be able to submit that text over to a server once you've established a TCP connection. And then the server will respond with the data from this resource. Let's mess around with the HTTP REST request APIs. We can do that using a text editor. I'm going to use Vim here. And what we're going to do is mess around with the variety of the structures of the REST API using HTTP, the protocol. Now, REST is going to have a set of verbs or request methods that we can use to make API calls and fetch data from a server or update data by writing data. And it's just text. It's just a text file. We're going to do this with a text file. Let's do this. Let's get started. So I actually kind of got it started here. So I built a text file here that is called request.txt. Yes, that's right. It's just a text file. We're gonna do this with just text. So I'm going to make an API call that is using the get verb. And then my path is going to be requesting a time. And then the protocol is HTTP 1.1. Notice that we are delimited here with a space in between the HTTP verb, the request method, the path. The path is going to be this URL here, and the protocol, HTTP 1.1. Then below that, we have a new line. We have a host header, so host colon space, and then the host itself. Now, let's actually use this payload. We're going to copy the data from this text file, and then you can already see the outcome here at the bottom of the screen, but we'll do that again. We'll walk through this. So we're going to read the data from the text file, and then we're going to, using plain text, because we don't want to worry about TLS connections right now, but we can do that as well. Read the data from the text file, which is all this data up here at the top, and then establish a TCP connection on port 80 to api.pubnub.com. And then I'm just going to press enter, and then the output comes. You get it works. We made an API call, a REST API call to a server endpoint that gave us back data. Isn't that cool? Which has been unexpected. All right, let's walk through that. Let's walk through the response really quick so you can see what's going on here. So we've got the response is going to acknowledge that the protocol is 1.1 HTTP 200. Okay. Now, of course, this is just text, so the server can send back whatever it wants here. It can send back like, okie dokie, it totally worked. A whole bunch of text there if it wanted to, and it would still be valid. Usually, though, HTTP just okay is what you'd expect. 200, this is an HTTP status code, and there are a list of status codes that the server will return. 200 is the one you want to see. You always want to see a 200 basically all the time, as much otherwise it's going to be an error for the most part, or some other action is going to be needed taken. The cool part is 200 is what you want. You might get some extra data here, like a time that the data was delivered, content type, connection data, content length, cache control. All of these are just, most part you can ignore them. You can ignore all of them if you wanted to. Though content length is kind of useful because it's going to return information about how long the response is going to be. And so you can see here there's actually 19 characters returned is a JSON array in a JSON array format in a large number that is representing a Unix timestamp in nanoseconds. So that's what this time API call is doing. And that we just made a request call to an API endpoint from a text file. I bet you didn't know you could do that. You can also change these things around. So like we can have like say, I love coffee, right? That should probably work too without any problems. I bet you it's going to work. Yep, same thing, totally work. It won't work if you remove the header because that's mandatory. So I'm going to get back an error. So I got back an error here, and the error said bad request. So that is required. However, if I change this to 1.0 and save it now, it'll work because you don't need the host header. So if you want the absolute minimal possible API call using the REST, you can use HP 1.0. The downfall is most clients, if you're using 1.0, will require you to close the TCP connection, which is a handshake that establishes a trust between the client and server. So you'll typically want to keep these things like that. So there we go. So that's going to be a nice standard for you to follow these days. See, it says connection keep alive, for example, which if you wanted to, you can keep the connection alive on the client side, though it's not mandatory.